Hi guys, I am Shubham and welcome back to Project Pandas. In this video, we would be learning how to delete and add columns and also how to delete rows. So let's get started. First of all, we would load the Titanic dataset and here it is. Let's say we want to drop the embarked column. One way is to override the data frame. How? By selecting just the columns that we want. So let me show you what I mean by that. Now so here we get a list which contains the name of every column except for embarked. Let's put it in a list and pass it to our data frame. So you see we have selected every column except for embarked, and if we want to make the changes permanent, we just have to overwrite it here. So now if you see that embarked column has been dropped permanently. Next, let's discuss the drop command. Let's say you have like 200 or 300 columns, and from that you want to drop around like just 4 or 5 columns. So it's not very practical that you would pass in a list of every column that contains name of every column except for those four. So better way to do this is using the drop command, and let's see how it works. So let's say we want to drop the name column from here. What we could do is we could specify drop, and we are trying to drop columns. So the parameter columns, and within a list, the name of the element, name of the column we are trying to drop. You see, it has been dropped. Although the changes are not permanent, you would have to pass the in place parameter to make the changes permanent or overwrite it. So let's say we can pass it any number of columns that we like. Let's say we want to drop name and passenger class. So if we do that, you see that the name and passenger class columns are not here. Although if you again the changes are not permanent. In order to make the changes permanent, let's pass in the in place parameter is equal to true, and if you see, the changes have been permanent. So that's all for dropping columns. Now let's talk about how you can drop rows. So let's say you know the index of the columns you want to drop. Let's say I know I want to drop 888 and 887. What I could do here is df dot drop, and within it uh, we want to drop rows, so that's why the index parameter, and within it 888 and 887. You see that these 889 comes directly after 886. That means they have been dropped. In order to make the changes permanent, let's pass in place is equal to true. So now the changes have been permanent. So let's take a case where I say I want to drop every column that every column that has no, not every column. Let's say that we want to drop every entry. Cut इतना cut copy paste करना है. So let's say we want to drop every entry that has age more than 35. Let's assume you are doing some analysis and it's crucial that you drop every entry that has age more than 35. So how you could do this with the help of drop function? Try to do it yourself. So let's see how it can be done. So first of all, I would filter the data frame df dot age is greater than 35. So we get all the entries that has age more than 35. Then we want its index. So we get the index. Let's save this index in some variable. Let's call it I and D. And now let's say df dot drop with indexes is equal to I and D. So now every column with age greater than 35 has been dropped. Let's make the changes permanent. So let's check it once more. Df dot we could use describe to see the properties, and in the age you see the maximum here is 35. So everything above 35 has been dropped by using this. So that's all for how you can delete certain rows, either directly by passing index or applying some filter, then taking its index, then passing into the drop command. Now let's talk about how can you add new columns. So as I have explained you earlier, there are basically two ways of I'm calling a column from a data frame. One is the dot annotation, another is the square bracket annotation. Let's say I call the age. I can also call age by this, like this. So let's say uh, I want to create a column that is twice the age of people. So I want to create twice age, column named twice age, which is basically two times the age. So how we could do that is, um, so in this we would pass in age star 2. So just like you multiply a variable in Python, you can apply a whole series. So you see everything has been multiplied by 2, and I want to store it as twice age column. So what I could do here is, so so let's first try the dot annotation. Df dot twice age, sorry, is equal to, so you see none of the error was, it was accepted, but still we do not see a column by the name twice age. So if we want to create a new column, we would have to use the square bracket annotation, and now if we do this, you see a new column has been added by the name twice age. So that's how you can add a new column with the help of an existing column. So any kind of operation you like, you can also have it divided by, let's say, divided by 2. This thing will also work, though the ages have been halved. Nan would remain nan, either you multiply it or divide it. So let's look at one more example. Let's say we want to create a column. If what it would do is, for if the passenger ID is smaller than 500, the column would contain the value 0. If passenger ID is greater than 500, the column would contain the value 1. So to do that, first we would need to create a placeholder. How we could do that placeholder? Let's say we create a column equal to passenger ID identifier. So passenger ID X, let's call it passenger ID X. And if we just to pass a single zero here, not a list, just a value, and we check data frame again, we see that a new column with passenger ID X has been created with every value as 0. But now what we want is, we want, instead of 0 in every place, we want some values to be replaced by 1, where the passenger ID is greater than 880, greater than 500. So first let's filter it. Df dot passenger ID is greater than 500. So all the entries with passenger ID greater than 500 has been selected. Let's use, let's call the PID X. Okay. So what is the, The error is that it actually wrote the small x and it's capital X. You see, we selected those only those rows. So let's make it equal to 1. And now if you check, so here's something interesting. Although you were able to you passed something in here, still the values didn't change. Even without throwing an error, the values remained the same. So in this case, what you have to do is that you will have to use the LOC operator or ILOC operator to filter it and then change values. So let me show you what I mean by this is. So if you type df.loc, and in the LOC operator, you can always pass in the boolean. And so if you remember, the first parameter of LOC is always the rows that you want to select, and in the place of rows, let's pass in this boolean, and we want to have every column, let's say. So you see, we were able to select those, but we don't want every column, we want just PID underscore X. Now if I make it equal to 1, you see that it has been changed to 1. So it's So what I would suggest is from now on make a practice to filter a data set based on by using LOC or ILOC operator, as it makes the changes permanent. Sometimes when you write code like this, you might end up getting errors although you are doing everything right. So that's one advantage of using LOC operator. Filter the data set according to LOC or ILOC, then perform the changes, and in that way you can be sure that your changes has been made permanent. So that's pretty much it for this video. Stay tuned for more. Thanks.